Welcome to Curie Electronics. Under microcontroller and applications, in this video we are going to see what is von Neumann and Harvard architecture. This von Neumann architecture is also known as Princeton architecture. As you know, this Princeton and Harvard are two top universities in America. This von Neumann was a mathematician. So these two universities developed different way of communicating CPU and memory, or we can say different method of interfacing memory with CPU. Let's see what is von Neumann architecture. So the von Neumann architecture, this architecture is related to computers, or we can say microcontroller, microprocessors. So here, how the memory is interfaced to CPU. So we have in the von Neumann architecture, we have CPU, then we have memory. This memory can hold data as well as we can say instructions or program or instructions. So this memory is a single memory. Here CPU can access using the bus whatever is stored in the memory, but it can be data or program. So the same memory holds data and program. This architecture is known as the von Neumann architecture. Then who decides what CPU is asking, whether data or program? There is something called memory interface. This memory interface decides whether the CPU is asking instruction or data. Memory interface decides memory access is for instruction or data. So in von Neumann architecture, data and program stored in a single memory that is interfaced with the CPU. This is a bus, that is including control bus, address bus and data bus. So at a time in von Neumann architecture, at a time or at any given time or instantaneously, either the CPU can fetch data or instructions, but not both. Now, what is Harvard architecture? In Harvard architecture, we have two memories, one for instructions or data, okay, or program, instructions or program, and one more separate memory for data. So in Harvard architecture, we have two memories, that is one particularly for program to store the program or instruction, and another one dedicated for only for data. Now in this Harvard architecture, the CPU can fetch instructions as well as data at the same time. It makes the execution faster. So this is the basic difference between the two architectures. That is the how the memory is interfaced with the CPU and whether the memory can hold data and program in same memory or different memory. If it is different, then it is Harvard architecture. Let us compare these two architectures. In the von Neumann architecture, common bus is used for data and instruction transfer. So in von Neumann, common bus for data and instruction transfer. So in Harvard architecture, separate buses for transfer of data and instructions. In von Neumann architecture, 2 clock cycles are required to execute single instruction. Because first you have to fetch the data, then instruction, or the instruction, then data, then we have to execute it. Harvard architecture, an instruction is executed in single cycle. So because simultaneously it can fetch data as well as instruction. In von Neumann architecture, pipelining is not possible. Pipelining means when you execute an instruction, we can fetch the next instruction or data. So it will speed up the processing. That is the pipelining. That is not possible in von Neumann architecture. In Harvard architecture, pipelining is possible. The CPU is not able to read and write and access instructions at the same time. In the von Neumann architecture, if the CPU is reading or writing, it cannot access the instruction. Reading or writing means it is for data. The Harvard architecture, the CPU can easily read-write data as well as access the instruction at any given time. And in the cost-wise, if we see, von Neumann architecture is less cost and Harvard is little more because of the two memory interfacing. And space taken, if we in the physical memory space, if we see, von Neumann architecture will take less space and Harvard will take more space. Then this von Neumann architecture we use mainly in computers, okay? Personal computer architecture, normal PCs, we use this von Neumann architecture. And this Harvard architecture mainly we use it in microcontroller. In microcontrollers, we use this Harvard architecture. Now I hope you got the basic idea regarding this von Neumann architecture and the Harvard architecture. In the coming videos, we will be learning more detail about the pipelining. In this series of lectures, what I have planned, we will start from theory, then we will get into 8051 microcontroller coding, then we go to PIC microcontroller coding, and finally we will take up LPC 1768, that is 32-bit microcontroller, and we will write the program and execute some example codes on a hardware, so that once you go through the series, you'll be able to develop your own embedded applications. If you like the video, please share with your friends and don't forget to hit the like button. Thanks for watching.